fractions, a chapter which is taught in grade 6, 7 and 8 I think, and for most of the classes wherein we understand what fractions is. Being children, we have understood that fraction is written in the numerator and denominator form. Okay, it has a numerator and denominator. So now we're just going to jump onto the types of fractions that we have. The types of fractions that we have is the first one, which is called as the proper fraction. Then we have the improper fraction, and we have the mixed fraction coming in the last. Okay, now what is a proper fraction? A proper fraction is where the numerator is small and the denominator is big. Okay, so it is going to be 3 upon 5 is the proper fraction that I have, whereas an improper fraction is the one wherein the numerator is going to be big and the denominator is small. Example, 7 upon 3. This is the improper fraction. Then you have a mixed fraction. What is a mixed fraction? If it comes in the form of a, b upon c, or I can say it comes as this part being a whole number and this part being the fraction, this combination is called as a mixed fraction. So 3 1 by 6 is a mixed fraction that I have in here. Now here what we usually do is we convert improper fractions to mixed fraction. What we do, we convert the improper fraction to mixed fraction and vice versa. So let's learn the first trick wherein I'm converting from improper fraction to mixed fraction. Okay, so here I have an improper fraction as 6 upon 4. Let's see. So what I am going to do is, this is an improper fraction. I will start dividing it. Okay, dividing 6 with 4 is what I'm going to do. So 4 ones are 4. Then I'm left with 2 as the remainder. I'll do only one step of division in here. Okay, only one step of division is what I'm going to do. Then I will start writing the terms in the a b by c form. So this is my a, this is my b, and this is my c in here that I have. So a b by c is going to be a is 1, that goes here, and then these two, that is 2 upon 4, would be the fractional mixed form. Okay, so if I have 13 upon maybe 6, let's say I have it here. Okay, then I'm going to divide 13 with 6. 6 2s are 12 is what I get, and 1 is the remainder. Then I start writing these in the form of a, b upon c. So my a is 2, b is 1, and c is 6. So this is the improper fraction. Okay, you're always going to go in the clockwise direction. Okay, starting from the top, which would be your a, then you go to the remainder, which is your b, and then you go to the divisor, which will be your c. Okay, this is what I go with. Okay, so here we have learned how to convert an improper fraction into a mixed fraction. Let's see another one wherein I have 27 divided by maybe let's say 4. So what am I going to do with 4? I'm going to divide my 27. Then 4 6 are 24 is what I get. I'm left with 3. Then I'm going to write it down like this, and this becomes my a 6. 3 upon 4. 3 upon 4 would be my improper fraction that I have in here. Likewise, you are going to convert the mixed. Now we have done the improper to mixed fraction. Now we are going to learn about the mixed fraction. I am going to convert it into the improper fraction. Okay, so how do I do it? Let's take a few mixed fractions, which is 6 1 upon 4 and 2 7 upon 9, and I have 13 4 upon 5. These are the ones. So what we are going to do is, first we are going to multiply these two and then add it to this one. Okay, so 6 4s are 24. 24 plus 1, the multiplication of this, we are going to multiply these two terms. Okay, and then whatever the answer that we get, we are going to add to this one. So it becomes multiplication here, the answer whatever it comes, it gets going to get added. So it becomes 25, and the denominator will be copied, 25 by 4. Here what did I say first? This undergoes multiplication. 9 7s are 63. 63 plus 2, which is 65. Denominator should be copied. Whatever the denominator is, what I'm going to copy it. Then 13 6 are it becomes 65. 65 plus 4 becomes 69. 69 upon 5 would be the mixed fraction of it. Okay, would be the improper fraction of the given mixed fractions. This is how we convert the mixed fractions to improper fractions and improper fractions to mixed fractions. This is the clockwise direction. From A, B and C is what we are going to write it here. Okay, now we have spoken about the different types of fractions. We have spoken about the proper fraction, improper fraction and mixed fraction. Also we have tried to convert the improper fraction into the mixed fraction and the mixed fraction into the improper fraction is what we have learned. Now another few types of fractions that are there, which is called as like fractions and unlike fractions are there. Now what are like fractions? Like fractions are the set of fractions that have the same denominator. Let's consider 3 by 4 and 6 by 4 is there. Okay, now when I look at this fraction, I can see that this and this have the same denominator. Okay, now if and unlike fractions would be like 7 by 3 and 2 by 9. These are the two different types of fractions that are there. These are the unlike fractions and these are the like fractions that I have. Now these like fractions, the identity of like fractions or usage of like fractions is done when you are comparing the comparing the fractions. So comparing the fractions is how do you do that? You do it wherein you put wherein you have the greater than, less than or equal to signs in here. Okay, so how do we actually compare the fractions? Let's suppose I have been given as 6 by 4 and 6 by 14, let's take, and there is another fraction which is 5 by 3 is there. Okay, now there are different types of fractions. Look, if they have the like fractions given, it's easy for me to compare them. Okay, if like fractions are given, like maybe 1 upon 9 is there and there is another one which is 7 upon 9. So what I can do is, मुझे पता है there was a complete fraction in which they made 9 sections. Okay, 1 2 3 4 5 6 7 8 9. Okay, 9 sections were made, and when it is talking about one section, maybe this is that one section, and 7 sections means everything leaving only one section. So I know obviously the 7 by 9 is bigger. So when I have the like fractions, it's easy for me to compare and tell which one is bigger. Here this one is bigger, so I can say 1 by 9 is less than 7 by 9, I can say in here. But how do I tell here what is the fraction? First of all, you have to see that can you reduce any of the fractions? I can reduce this fraction. So 2 times table. Okay, every time in fractions, now that we are at a higher grade students, we have learned to reduce the fractions, so we are going to apply that logic in here. Okay, so what I'm doing is I am reducing the fraction with times 2 table. 2 3s are 6, 2 7s are 14. Okay, so now the fraction that I got is 3 by 7 and 5 by 3. Even after reducing, these two fractions are completely different. Now what I am going to do is, when I have this, I will start taking the LCM of it. 3 comma 7. So 3 1 times 3, 7 won't come in 3 tables, so I'm going to write that 7 down again. Okay, then I have again the times 3 table, 7 table I'm going to do. 7 7 3 was already completed. 7 1 doesn't matter, I'm not going to touch it at all. Instead I'll do 7 1s are 7. So 3 7s are 21 as the LCM here. 3 7s are 21 as the LCM. So here I have to make the denominators 21 for both. Okay, so I have to make the denominator as 21. How do I make the denominator as 21? To make the denominator 21, 7 ko I'm going to multiply with 3. If I'm multiplying anything with the denominator, the same thing will multiply with the numerator. Here I will multiply with 7 and here I will multiply with 7. So 3 3s are, it becomes 9. 7 3s are 21. And now it is 21 here. 3 7s are 21, 5 7s are 35. Okay, so which one is bigger now? 35 upon 21 is a bigger part, isn't it? So I can say that this fraction is bigger when compared to this one. So I'm going to write 9 by 7, 9 by 2 is less than 35 by 21 is what I'm going to write it down. Okay, now they will come fractions if it is like, sometimes in fractions, this is how you compare. Okay, sometimes there's a rule in fractions. Okay, the first rule is that same
Denominator if they have, same denominator if they have, bigger numerator means the bigger fraction. Okay, big fraction will be there. Okay, that fraction will be the big one. The second is sometimes the same numerator will be given. Same numerator will be given to you. Then the smaller the denominator, smaller denominator means the big fraction. Okay, that means the big fraction. Third is if there is no same denominators. Okay, you can have even the same denominators or same numerators. If both the conditions are not there, then no like fractions. Okay, if there are no like fractions, then you have to make them as the like fractions. Then you have to convert them to like fractions. Convert them to like fractions. And how do you convert them to like fractions? Using the LCM method. Okay, now this is not just used in comparing quantities. Also, when I want to arrange some fractions in ascending or descending order, then also I'm going to use the same thing in here. So let's do a few questions where we are comparing the fractions. Okay, so comparing fractions is what we're going to do in here. The first one that is given to me is 4 by 6 and the other one is 12 upon 12. Now here, if you look at this one, I can very well say that if I just try reducing, because they both come in the same table of 2, they both come in the table of 12. Okay, they come in 2 table also, they come in 3 table also, and they come in 6 as well as in the 12 table. So I'm going to take the bigger table in which they are going to come. Okay, so this, for this one, 2 is the maximum table. 2 2s are 2 3s are. So this fraction becomes 2 by 3, and this fraction becomes 2 by 2 means 1. 1 means what? 1 means the complete thing. Okay, the complete thing without any division. Okay, so this is actually the 12 parts of 12 parts. Okay, I have this parts and this is the thing. So 12 parts out of the total 12 parts. That means it is talking about the complete thing. One complete thing के बारे में बात कर रहा है. And 2 by 3 parts of it. One complete means पूरा हो गया. And when I say 2 parts of 3, okay, so this is the parts that it is talking about. So which one is bigger? Obviously the 1 will be bigger because it is a complete one. So 2 by 3 is less than 1 is what I get in here. The second one that we are going to see is, so this is how we're going to compare the fractions. This is a must for the basics to be learned while doing this thing. Okay, I have 6 by 9 and I have another one which is 6 by 9. They both are the same fractions, so they're equal fractions in here. Then I have 1 upon 11 and I have 1 upon 6. What did I tell you? That the one with the bigger, when they have the same numerator, so this is the rule. Same numerator means the smaller the denominator, the bigger the fraction. Okay, the smaller the denominator, the bigger the fraction. So this is less than 1 by 6 is what I get in here. Okay, now after this I have another one wherein we can take it as, yeah, 7 upon 8 and I have 3 upon 10. Now I will start taking the LCM for this. Okay, so when I take the LCM, because the denominators are not equal, no like denominators means I have to make them as the like fractions, and by taking the LCM, so times 2 table, 2 4s are and 2 5s are. Then again 2 2s are 4, 2 5 will not come, so I'll leave that 5 again like that itself. Then 2 1s are, and 5 will remain as it is. Then 5 tables separately I'm going to use, and then I'm going to do. So the LCM is 2 2s are 4, 4 2s are 8, 8 5s are 40. 40 is the LCM. So here I have to make the denominators as 40. So to this one I'm going to multiply by 5 to make it 40. Also this gets multiplied by 5. Whatever I multiply in the denominator, same thing has to multiply to the numerator. To make this 40, multiply by 4 and this multiplies by 4. That becomes 35 upon 40, and I have 3 4s are 12 upon 40 is what I have in here. So which one is a bigger one? 35 upon 40 is a bigger one because numerator is bigger. So this is greater than this is what we are going to write in here. Okay. Let's take the fractions like I have 1 by 2 and 3 by 7. So again what I'm going to do is I'm going to take the LCM and try making them same. So 2 and 7. 2 1 times and I have 7 won't come in two tables, it will be written as it is. Then I have to go with the 17. So 14 is what I'm going to get. So here when I get the 14, that means I have to multiply with 7, multiply by 7, multiply by 2, multiply by 2. So that becomes 7 ones 7 upon 14, and then I have 3 to 6 upon 14. Denominators are same, bigger numerator is the bigger fraction. So this one is bigger than this one is what I get. Okay, likewise I have another one wherein 1 by 6 and 2 by 4 is given to me. Now here what did you see? 2, let's get an idea. Here what did we see was I had 1 by 2, 3 by 7. 2 was never going to, let me just write it down. This was the question given to us. 3 by 7. I saw that time in, however, if I want to make the denominator same, it is not possible because both of them are prime numbers. They do not come in each other's table. So what is that thing that I did? I can take the LCM, but always LCM is not flexible. When we are short of time, we can understand that to make the denominator same, because they are prime numbers, I have to multiply this number with the complete fraction here. Okay, that's what I did in here, isn't it? The 7 was multiplied with this because I took the LCM and I got the LCM as 14 here. To make it 14, what did I do? I multiplied it with 7. But to understand what is actually happening is when we have the prime numbers, this denominator can only become same if I multiply the opposite numbers in here. So 7 multiplies with this fraction and this 2 multiplies with this fraction. See over here, 2 multiplied with this complete fraction and this. So if I have 3 by 5 and I have 6 by 4, let's say, okay, then they both don't come in the same table. So what I'm going to do, this will multiply with my complete fraction here. So multiplied by 5, multiplied by 5, and this 4 will multiply with my complete fraction here. Multiply by 4, multiplied by 4 is what I get in here. So this becomes 12 upon 20 and it becomes 30 upon 20. Then I can, denominators are the same, I can do that. Okay, so this is how we need to understand. But look over here. Here what is happening, 6 and 4, I can still not make them same. Why? Because they come in the same table, but how much will I multiply to 4 to make it a 6? We are always looking up to multiply, not add. We are looking to multiply, not add. No addition. Okay, so what am I going to multiply with 4 to make it a 6? I cannot do anything here, isn't it? So instead what I'm going to do is, again I have to make the denominator same. Again the same method. LCM is 6 and 4 times 2 table. 2 3s are 6, 2 2s are, then again go with 2 table. 2 3 will remain as it is because 2k table may you don't get the 3. So 2 1s are 2, and then I'll go with 3 table this. So 2 2s 4, 4 3s 12. LCM is 12. I have to make the denominators 12 now. So to make it 12, multiply by 2, multiply by 2. To make it 12, multiply by 3, multiply by 3. So it becomes 2 upon 12 now, and it becomes 6 upon 12. Okay, so which one is the bigger one? Obviously this one is the bigger one. So I'm going to say 2 by 12 is less than 6 by 12. Okay, so here we understand if they are complete strange numbers which cannot come in each other's table, just cross multiply them. But if they come in same table and still you cannot make the denominators equal, go with the LCM is what we understand in here. Let's look at another question in here which says 7 upon 13 and I have 10 upon 12. Now 12 and 13, they will not come in each other's table. Then what am I going to do? This multiplies with this one times 13 and times 13. This multiplies with this one times 12 and times 12. So 7 8s are, how much am I going to get in here? Sorry, 7 12s are we are supposed to do. 7 times 12 is equal to 84. 84, and then I have 13 times of 2, right? Sorry, 13 times of 12. So how much will that be? 13 times 12 times 12 is, so most of the time students will be having difficulty in doing 13 times 13 and so on and so forth. Either you can do the multiplication, or you can do 12 times 12, that is 144. To that add 12, so it becomes 156. Okay, so I have it here, whatever the denominator, 12 13 12 13 only, so 156 is the denominator I get. This multiplies 130, it becomes, isn't it? So which one is the bigger one now? Obviously this one is the bigger one in here, so I'm going to say this is less than this, is what I can say info from here. Okay, what if I have a fraction like, let's say I have a fraction like 7 upon 8 and something about 64. Okay, now the whole idea is to make the denominator same, isn't it? The complete idea is to make the denominator same. So maybe let's say here it is 12 something. Okay, then what am I going to do in here to make the denominator same? Can I multiply 8 with something to make it 64? Yes, I can multiply with 8, another 8 times of 8 I can do, that becomes a 64. Then I can just multiply an 8 here. Here do I need to multiply anything? Because both the denominators are same now. This has become 64, this is also 64. I do not need to do anything in here. So 7 8s are 56, 56 upon 64, and then 12 upon 64. This one is a bigger fraction anyways, so this is greater than this, is what I'm going to do. So these are the different options that you get, methods of questions that you get, wherein the denominators are completely strangers, you have to make them cross multiply them. Denominators are similar strangers, 6 and 4, they come in the same table, but I cannot make it unless and until I take the LCM. Okay, sometimes denominator, just multiplying with the same thing, you get the other thing. Okay, if I have 2 and I have let's say I have 12 and I have 36 denominators, just let's say x and y is here. Don't get confused or don't get scared why have ma'am taken x and y, just I'm talking about the denominators in here. So 12 can be converted into 36. How? I can multiply this with a 3 to make it a 36. Also this needs to be multiplied by a 3 then, because whatever I'm multiplying to the denominator, the same thing has to be multiplied to the numerator to make it similar. Okay, likewise you will have questions of arranging the fractions in the order. Okay, so you have either ascending order or descending order. Okay, so what is ascending order? Ascending order is going from small to big. Okay, and descending order is when you go from big to small, isn't it? Now, so the question that is given over here is 1 upon 2, 7 upon 10, 1 upon 6 and 3 upon 4 is the question that is given to me. Okay, now I have to arrange it in the ascending order. Okay, fine. So what is the ascending order? I have to go from small to big. Then how do I know which fraction is big and which fraction is small? Now here what I can do is I have to make the denominator same. First and foremost thing is to arrange, to compare, to add and to subtract. The denominators need to be the same. Okay, four operations: to compare, okay, to arrange, I have missed the in here, and to add or subtract. This is a condition that these denominators need to be the same. So here, how do I make the denominator same? They all are the similar ones. I can make 2 and 4 same, 2 and 3 same, 2 and 10 same, but overall the denominators cannot be same. Then the only thing to rescue is LCM of these numbers with the prime numbers. Okay, so 2 times 2 1s are 2 5s are 2 3s are 2 2s are, and I'll go with 2 only because I have one term left with 2. So 2 1s times 5 3 2 1s are 2. 5 and 3 I have to do it individually. So after 2 the next prime number is 3, so I'll go with 3 only. So 1, 5 remains as it is undisturbed, and 3 ones are 3 it has become, and then 1. Then 5 again. 5 1 times is what I get. This is the end. So here the LCM is 2 times 2 times 3 times 5. Most of the students who are in grade 7, they'll do the multiplication here itself. But someone who are learning it for the first time, you can do it, write it down like this, and then do it. 2 2s 4, 4 3s, 2 2s are 4, 4 3s 12, 12 5s 60 is the LCM. Okay, 2 2s 4, 4 3s 12, 12 5 60 also. So I have to make the denominator 60 for all of them. How do I make it with 2? I know if I multiply 2 with 30, it becomes 60, isn't it? If I multiply 2 times 30, it is 60. Some students are there who do not know how to make it a 60. 2 is a very small number. For them, 60 is a very big number. Then you see, 2 is here. From here, skip the 2. I'll take a pencil and I'll do it. So what I'm going to do is, 2 is here, leave the 2. Rest all needs to be multiplied in here. 2 3 6, 6 5s are 30. So I'm going to multiply this with 30. Understand? Now, I have to make 10 as 60. Simple. I can just multiply with 6 and I get the answer there, isn't it? But some students do not know how to multiply. Everyone will be knowing how to multiply, make 10 as 60 just by multiplying 6. Okay, but what am I supposed to multiply to 6 to make it a 60? Multiply by 10, multiply by 10. Then now, what am I supposed to multiply with 4 to make it a 60? I don't know. So 4 is here. 2 2s 4. 4 is here. Leave this. Rest all you have to multiply here. So 3 5s are 15 I have to multiply. So 15 I have to multiply in here to make it a 60. Then further ahead, it would so happen that once we have got this, the denominators are all same now. What happened to the denominators? They have all become same now. So 1, that becomes 30 upon 60, comma, it further becomes 7 6 are 42 upon 60, comma, 10 upon 60, comma, 45 upon 60. Now can you arrange them? Denominators are same. The smaller the numerator comes first. So this, it is 10 upon 60, comma, 30 upon 60, comma, 42 upon 60, comma, 45 upon 60 is what I'm going to do in here. Okay, so now 10 upon 60 is which fraction? It is 1 by 6. So I am not going to leave my answer here. They asked me to arrange this in the order. So I'm going to write 1 upon 6 for this one. 30 upon 60 is which one? 1 upon 2. So comma 1 upon 2 comes in here. Then 42 upon this, which is that one? That is 7 upon 10. So 7 upon 10 comes in here. And then the last one, that is 3 upon 4 would be the ascending order of this particular question. This is how simple it is. You just need to make the denominators same. Once you have made the denominators same, arrange them, and then you are going to fix it up like this. Okay, let's take on the second question, wherein we have been given something as this: 3 upon 7, 6 upon 21, and 2 upon 14, 4 upon 7, and 3 upon 21. Now when I look at this, they are clear multiples of 7. They are the clear multiples of 7. So again, what I can do is, the bigger one is 21. So all of them have to become the 21. Can I make 7 can be made to 21, but 14 cannot be turned to 21, because what will I multiply with 14 to make it a 21? Not possible. So again, what we are going to do is, we are going to take the LCM of it. Okay, now let me do the LCM for it. It is 7, 21, 14. Again, I have the 7 and 21, so I need not repeat it again. Okay, I'm not going to repeat that all over again, because I already have the 7 and 21. Then 7 1 times 7, 7 3 times 21, 7 2 times 14. Then I have to go with 3 table or 2 table. I can go with 1 1 and 2, and then times 2 table. This is what I get in here. So the LCM is 3 sevens are 21, 21 times of 2. Okay, so the LCM, what did I tell you for LCM? You just need to multiply like this also. 7 threes are 21. 21 times of 2. You don't know how to do it here. You know how to do it here. 2 ones 2, 42. Okay, so all of that has to become 42. So it's n times table of 7, where does 42 come? It comes with 6. Some students have, they're very weak at tables. Where does it come? The times 2 table and times 7 table, where does 42 come? I don't know. What am I supposed to multiply with 7 to make it a 42? I don't know. Then 7 is here, leave that 7, take the rest. 3 2s are 6, so I have to multiply with 6 in here. I have to make 21 as 42. Okay, because the LCM that I got is 42. Write down the LCM here so that you know what you are supposed to make. Then 21 is here, that means 7 and 3 is here. Chuck this off. What is left? 2. Just multiply with it. 14. 7 times 2 is 14. Now what is left? 3. So I'm going to multiply this with 3. Then again 7 is repeating, so the same thing you have to copy it down from here. 21 was multiplied by 2, 21 was multiplied by 2. That's how you're going to do it. Okay, then so now what we're going to do is we are going to write down the fractions. 3 6 are 18, 18 upon 42, comma 12 upon 42, comma 6 upon 42, comma this becomes 24 upon 42, comma 6 upon 42 again. Okay, so arranging them, the 6 upon 42 comes the first one. Okay, 6 upon 42, and then I have another 6 upon 42, so write them. The order doesn't matter because they both are the same. Okay, then 12 upon 42, 18 upon 42, and last one is 24 upon 42. But this is not what he asked me to arrange. He asked these to be arranged in the order. So what I can do, 6 upon 42, where does it go? It goes here. So the first one is 2 upon 14. Okay, then I can do this as another 6 upon 2 is 6 upon 42 is this 3 upon 21. Then it is 12. 12 is this 6 upon 21, comma 18. 18 is the first one, 3 upon 7, comma this one 24, last term, which is nothing but 4 upon 7. 4 upon 7. This is how I am going to arrange them. This was one method. In this question, I can solve it with another method. Let me just show you that as well. The question that we had was 3 upon 7, comma 6 upon 21, 2 upon 14, and we have 4 upon 7 and 3 upon 21 is what I have in here. Okay, now I have to arrange it in order. Look and assume we are not doing the LCM in here. Look, the way I said look, I scared people. Okay, what I can do here is I can reduce the other fractions to make and see also. This cannot be reduced, it remains 3 upon 7. But can this be reduced? Yes, with times 3 table. 3 2s are, 3 7s are. So 2 upon 7 this one. Then can this be reduced? Yes, by 2 times table. 7 1 times, sorry, 2 1 times, 2 7 times. So 1 upon 7 we are getting. This is anyways 4 upon 7. Just write it down. You cannot reduce it. This can be reduced, yes. 3 1 times, 3 7 times. So 1 upon 7. This could, or the question that we have just done as with the LCM method could also be arranged like this. Okay, you can also arrange it like this by reducing it also. So you will have questions where you are required to find the LCM. You will have questions where you can just reduce them and the denominators become the same and you can get your answers. Rearrange them now. 1 by 7, 1 by 7, that is 2 upon 14, 3 upon 21. 2 upon 14, comma 3 upon 21. They are the same. Then I have 2 upon 7. 2 upon 7 is nothing but 6 upon 21. Then I have this one, 3 upon 7. Let me write 3 upon 7. Then I have 4 upon 7. 4 upon 7. That's it. I have arranged it in the ascending order again. Descending order would be the reverse order of this one. Simple.